Good afternoon. Thank you, Honorable Teacher, giving me the opportunity to say something about this research paper presentation. Today's presentation topic: analysis of cognitive complexity with cyclomatic complexity matrix of software. Today's presentation presented to this is Saiful Islam, and today's presentation presented to MD Hassan Imam, lecturer, Department of Software Engineering, Institute of Information Technology, Noakhali Science and Technology University. Here is my presentation draft. Introduction, literature review, research method, discussion and result, and conclusion of this presentation. First, I discuss about the background, that means introduction of my presentation. Here is the two terms. First one is cognitive complexity and another one is the cyclomatic complexity. Cyclomatic complexity is the well-known term of software domain, and another one is the cognitive complexity. Cognitive complexity is the new term of software matrix. Cognitive complexity has many research paper published already published about complexity, cognitive complexity, but cyclomatic complexity is the well-known term of in our software domain. So now I discuss about the introduction of my presentation. Software complexity measured to cause the developing of software, deployment time, and the work needed, the understanding of the program, and it is determining the complexity to the system of component. On the another part is the cognitive complexity. Cognitive complexity mainly work the human brain, how work is processing. On the other hand, cognitive complexity comparison between the coding language like C hash, C++, Java, etc. Now I am going to my next part, the literature review. It is the most important part of my presentation topic. I discuss about two research paper. First research paper is a performance evaluation and improve complexity, cognitive complexity and other code basis. Mainly this paper discuss about the difference between the cognitive complexity and coding language. Here discuss about the four coding language. First one is C hash, second is C++, and Java. So mainly here propose about the C hash, C short, mainly C short. So here but we analysis the cognitive complexity and cyclomatic complexity research about the mainly human brain, how to work the software. But here discuss about the how to comparison between the coding language on this other basis. Now I am going to my second research paper analysis, and here discuss about the analysis enhancement of the cognitive complexity based on complexity measure. In this paper, discuss about a possible approach to quantify the software complexity. Use the cognitive informatics, which measurement is mutual work involve the cyclomatic complexity and cognitive complexity. Here mainly work about the how to human brain comparison and writing program and analysis work into the software field. But here not discuss about the comparison between the cyclomatic complexity and the cognitive complexity. But this research paper apply the many approach. Now I am going to research method. Here is the three problem I discuss about. That means in this paper discuss about the three methods. First one is the cognitive complexity. Second one is the cyclomatic complexity matrix in software, and third problem is relation between the cyclomatic complexity and cognitive complexity. Is the here research another method. Is the method one is cognitive now I discuss about the mainly what is the cognitive complexity. Here cognitive complexity refers area of cognitive complexity informatics that examine the underlying working the human brain. Informatics the processive system of the software program. And my another part is the method 2. Method 2 about this discuss about the mainly most important part, which work with the linear path of LOC. That means the line of code is mainly work the linear path. Yes, here makeup introduction method introduce the cyclomatic complexity matrix, who is the quantifier structural complexity module, by considering the control flow. Mainly cyclomatic complexity discuss about the control flow diagram, which comes from the LOC. Mainly control flow diagram works line by line code, works between the line by line code, but cognitive complexity not work with LOC. It's mainly work the human brain, which one is the discuss my paper. Here is the relation between the cyclomatic complexity and cognitive complexity. Mainly here is the three column. First column is cognitive weight. Second is the spatial capacity. Third one is the cognitive complexity, and fourth one is the makeup cyclomatic complexity. When the cognitive complexity weight is high, what is high, BCS also high. BCS mean the basic structure of code. And spatial capacity also high, cognitive complexity also high, and cyclomatic complexity also high. That means we understand about the when cognitive complexity high, all are high. And next one is when data type structure is high, basic structure of code is also high. Spatial here is the difference between the spatial capacity is low, and cognitive complexity medium, and the cyclomatic complexity high. Here is the discuss about the relation between cyclomatic complexity and the cognitive complexity. And may I briefly discuss about the paper which I will submit in Google Classroom. And here is the cognitive information quality matrix, and a line of code, and cyclomatic complexity, which is the understand between the which result comes with difference between each other. And here is the graph. Mainly this graph discuss about the cyclomatic complexity, which is work with the C++, and Java language. Here is the conclusion of my presentation topic. Mainly this paper discuss about the analysis the cyclomatic complexity and cognitive complexity matrix in software design. So here there are mainly two terms. Again and again said this two terms. Cognitive mainly discuss many research paper already published about the cognitive complexity, but cyclomatic complexity is normal. It's published many ways, but cognitive complexity nowadays research increase day by day, but it has no conclusion. Thank you, honorable teacher. Thank you.